I have two polar equations. I graph them. The first one is a red circle, r equals to -6 cosine theta. I have a red circle. And then the other one is a cardioid, r equals to 2 minus 2 cosine theta. That is in the blue cardioid. This one I use decimal to graph them. And then what they are looking for is they want you to find the area of the region lying inside the circle and inside the cardioid, which is the pink region. This problem isn't that easy. This problem will take lines and lines of math to get to the final answer. To start the first step, we need to find the intersection. This one isn't that easy. Okay, let me just state what we are trying to do. Find the intersection. So find the intersections and draw the radial lines. Okay, intersection of what? So back into studying area between two curves. So let's say you have a parabola, you have a straight line. Find the intersection means you set the two functions equal to solve for x. This one, I will set the two polar equations equal to solve for theta. So 6 cosine theta, I set that equals to the blue cardioid, 2 minus 2 cosine theta. Let's put all the theta on one side. I will add 2 to the left-hand side. So -6 cosine theta plus 2 cosine theta equals to 2. -6 plus 2, -4 cosine theta equals to 2. And then I will divide both sides by 2. Then cosine theta is equals to -1/2. And then you need to use your unit circle to solve for theta. Cosine is for the refers to the x coordinate. X coordinate is negative in quadrant 2 and quadrant 3 of the unit circle. So this one theta is in quadrant 2 and quadrant 3 in the unit circle. Then you go to your unit circle in quadrant 2 and quadrant 3, which angle gives you a negative x, and then x is equals to -1/2, and then they are theta equals to 2 pi over 3 and 4 pi over 3. So when theta is equals to 2 pi over 3, that is right there, 2 pi over 3, and then 4 pi over 3, that is right here, 4 pi over 3. And then we call this the radial line. So this one, 2 pi over 3 and 4 pi over 3. 2 pi over 3 radial line. 4 pi over 3 radial lines. And then if you zoom in a little bit, do you see that this radial line cuts a region right here? So that region, I am going to use blue to fill up this gap. So this blue region is between the circle and the radial line. And then how big is that region? That's what we have to find out. And then this is from pi over 2 to 2 pi over 3. So I am going to say the green region is inside the circle. And the cardioid. And then this is from theta equals to pi over 2 to theta equals to 2 pi over 3. Okay, then the area is equals to integral. You visually put the 1/2 in front, outside. And then from pi over 2 to 2 pi over 3, we square according to area of a polar equation. That is 1/2 times integral lower to upper limit. We square the polar equation, which is this time is touching the circle. The green region is clearly touching the circle between the red circle and the radial line. Then I will just square the circle. The circle is -6 cosine theta. Okay, let's move this up. cosine theta. And then you square that. I have a 1/2 integral from pi over 2 to 2 pi over 3, 36, and then cosine square theta d theta. We cannot integrate sine square and cosine square. Therefore, we must use the power reducing formula. Power reducing formula. Power reducing formula. If you watch my other videos, this formula is pretty much used in almost every single problem. I have a cosine square theta equals to 1 plus cosine 2 theta divided by 2. Okay, and then 36 divided by 2, so 36 divided by 2, and then pi over 2, 2 pi over 3, we have divided by 2, and then 1 plus cosine 2 theta, and then a d theta. Okay, now we have a 36 divided by what? Divided by 4, right? So this one, the 36, let's use a highlighter. These are 36, the 2, and these 2. That is a 36 divided by 4, which is equals to 9. So I have a 9 integral pi over 2 to 2 pi over 3. And then I have 1 plus cosine 2 theta d theta. And then we integrate. This is a theta. The integral of cosine is sine. Sine of 2 theta. I prepare a 1/2 in front. Take the derivative. That gets you back straight to the integrand. Such that from pi over 2 to 2 pi over 3. Okay, fundamental theorem of calculus, plug in 9, and then a 2 pi over 3 plus 1/2 sine 2 times 2 pi over 3, that is a 4 pi over 3, and then minus by fundamental theorem of calculus 9, and then pi over 2 plus 1/2 sine of pi. Okay, this one looks pretty good. Sine pi is 0, so that gives you a 0 immediately. You need to distribute this negative sign, and then I will pull the 9 out. I have a 2 pi over 3, and then sine of this one, sine of 4 pi over 3, that is negative root 3 over 2. And then this one gives me a minus root 3 over 4, and then minus a pi over 2. So all that is for the green area. Just one little region right there. I also have another piece down below. I will multiply by 2 to get the total, but we will do that at the end. So now we have the green area. So this green area is found. Okay, I'm going to draw the radial line one more time. This is at 2 pi over 3. And then the green area is found. And then the next area that we have to look for is this purple area, this purple region. So purple region from theta equals to 2 pi over 3, and then to theta equals to pi. And then this region is inside the cardioid. And then I have area equals to 1/2. Okay, this is from where to where? Continue from 2 pi over 3, and then this one will be all the way to a pi. From 2 pi over 3 to pi. 2 pi over 3 to pi. And then I will square the cardioid, and then d theta. The cardioid is 2 minus 2 cosine. Okay, then you open up the square. This is 1/2 integral. Open up the square, you have 2 times 2, minus 4 minus 4, and then 2 times 2. Okay, I see a cosine square. Then that triggers another power reducing formula. Power reducing formula. And that is a cosine square theta equals to 1 plus cosine 2 theta divided by 2. and then we have a 4 times that. Okay, I have a 4 multiply this, duplicate 4 multiply this, and that produce a 2 1 plus cosine 2 theta, and then this is a 2 plus 2 cosine 2 theta. Okay, let's put this back to my integral. So I will just duplicate and then put this right here, and then I have a d theta. Okay, what do we get? I have a 4 plus 2 equals to 6. Okay, 4 plus 2. Okay, let's just 4 plus 2 is equals to 6. And then I want to distribute the 1/2. Distribute the 1/2. And then after the distribution is done, 6 divided by 2 is 3. 8 divided by 2 is 4. And then 2 divided by 2 is 1. Okay, then we integrate one term at a time. That is equals to 3 theta minus 4 sine theta, and then plus sine 2 theta. There is a 1/2 in front. To check your work, you simply take the derivative. And then this is from 2 pi over 3 to pi. 2 pi over 3 to pi. Okay, plug in. I have a 3 times pi minus 4 sine pi plus 1/2 sine of 2 pi, and then minus 3 times 2 pi over 3 minus 4 times sine of 2 pi over 3 plus 1/2 sine of 4 pi over 3. Okay, I see something that is great, because sine pi and then sine of 2 pi, they are all 0. Okay, great. And then what else? Sine of 2 pi over 3, this is a root 3 over 2. And then sine of 4 pi over 3, this is a negative root 3 over 2. Wow, what do we have? I have a 3 pi from the first bracket, and then you have a distribution. Don't forget that you have a distribution minus 2 pi, and then plus 2 root 3, and then minus, minus plus, then that will be a plus. Then this is a root 3 over 4. And then 3 minus 2 is 1, so pi plus 2 root 3, and then plus root 3 over 4. So this is the purple region area. Okay, what do we have so far? We have a purple, we have a green. Okay, let's add them. Let's add that to the green. And then purple plus green. How about this? Plus the green region area. When you add them, what do you get? When you add them, what's the green? Wow, you know what? The green, I still need to do a distribution. Can we just do that? 9, I'm talking about this distribution. So this will be a 3 times 2, 6 pi. Okay, what's next? And then 9, and that will be a 9 root 3 over 4 in sub minus. 9, can I put that in here? Oh, okay, 9 root 3 over 4. And then next, 9 and that, so that will be a 9 pi over 2. Okay, 9 pi over 2. In plus or minus? Minus. Okay, minus 9 pi over 2. Minus 9 pi over 2. Whoa. Okay. Let's do the pi. Okay, this one is a 7 pi, and then a 9 pi over 2. So 7 and then 14, right? 7 pi minus 9 pi over 2. 14 minus 9 is equals to 5. So that will be 5 pi over 2. Let's use a different color. So this one is 5 pi over 2. And then what else do we have? I have okay, here this is minus 9. You add 1, that is negative 8. Negative 8 divided by 4, that is a negative 2. Plus 2 minus 2 is gone. So that is what you have. So this one is the upper half. So this one is how do I call this? This is from theta equals to pi over 2 to theta equals to pi. And then I have another graph right here. So that how much is this? Okay, let's put this line back. And then, okay, actually, I don't need to do that. That is that much. That will be the upper half. Okay, shade this region upper half, and then I will call this 5 pi over 2. So this is a 5 pi over 2. I have another 5 pi over 2, then 5 pi over 2 multiplied by 2, that is 5 pi. What is this? So this is the total area of the region lying inside the circle and inside the cardioid. Lying inside the circle and inside the cardioid. Okay, and there we go. Then that is the end of this problem. So all that piece of work for a 5 pi. So all this work, 2.5 pages, just for a 5 pi, which is normal in this type of problem. Okay, if you like the way I explain this type of problem, my explanation is clear, you really like this, you want to see something similar, click the like, click the subscribe, and I will meet you all in the next video.